Hi again everyone. In this simple video we're going to continue our look at infinite series, and in particular we're going to discuss the limit form of the comparison test, just a simple version of it. So here is the limit form of the comparison test. So suppose we're given an infinite series sigma an where all the ANs are positive. If we can construct another series, sigma bn, with each b sub n positive, such that the limit of this ratio is some positive finite value, then either both series converge or both series diverge. Okay, so you may think, what's the relationship with this test with the regular form of the comparison test? Well, sometimes this is more easier to apply. You don't have to fiddle around with inequalities like you do with the regular comparison test. So let's have a look at how we apply this form of the comparison test on this particular example. So we're given some infinite series here and we're asked to discuss the convergence or divergence of the series. Okay, so what we in essence have to do is construct a new series, sigma bn, and then test the limit of this ratio. If that limit is a positive and finite value and the new series diverges, then the original series also diverges. And if the limit of this ratio is some positive finite value and the new series converges, then the original series converges. Now, the big question is, how do we construct this new series? Well, for rational type functions, a good idea here is to look at the highest power in the denominator, look at the highest power in the numerator, and then choose a p-series where you take one power away from the other. So in this case, I see, right, great, the highest power down here is 4, the highest power up here is 1, so let's choose sigma bn to be sigma 1 on n cubed. Okay, now the next thing we have to do is check the limit of this ratio. So let's consider that. So I want to look at the ratio between this, the limit of the ratio between this and this. Now I'm going to multiply by the reciprocal here. Okay, so now it's up to us to evaluate this limit. So I'm going to simplify this as much as possible. And I'm going to end up with something like this. Okay, so now here what I'm going to do to evaluate this limit is to divide top and bottom by the highest power in the denominator, which will be n to the power 4. So if I divide the top by n to the power 4, I get this. And then if I divide the bottom by n to the power 4, I'll get this. Okay, so now let's take this limit. The limit of the top is going to be 3. The limit of the bottom is going to be 2 to the power 4. So I'll get 3 on 16 for the limit of this ratio. Okay, so let's look back. Is the limit of our ratio positive and a finite value? Yes, it is. So now the last thing we have to check is, well, whatever this new constructed series does, the original series will also do. So if we look here, this is a P series with power equal to 3. And a P series with power equal to 3 will be a convergent P series. Okay, so we note that our new constructed series is a convergent P series with P equal to 3 and in particular strictly greater than 1. So let's make our conclusion by the limit form of the comparison test. Our original series must also converge. Okay? So we've named our tests, we've come to a conclusion, and a really good way of remembering how to choose this new series is to look at the difference between the powers here and choose a P series accordingly.